Welcome everyone, I'm Bartosz Nowicki, and today I'm excited to walk you through our DFMEA Lite methodology training. Let's dive into how we can make our designs robust. Welcome to the hierarchical structure of our DFMEA Lite program, designed to build expertise from the ground up. You are currently looking at the various tiers of our DFMEA Lite belts, starting from the foundation and culminating at the expert level. Each belt signifies a specialized knowledge set tailored for distinct roles within our organization, ensuring that every team member is equipped with the right expertise to excel in their duties. Today, we will delve into the intricacies of the blue DFMEA Lite Foundation belt, which is crafted for general management. This foundational level is crucial as it lays the groundwork for understanding the principles and applications of DFMEA. As we progress, we encounter the green DFMEA Lite Practitioner belt. To attain this level, one must have successfully completed the foundation belt. The practitioner belt is targeted at team members who are in direct contact with the code on a day-to-day basis or those who are in charge of managing these critical operations. The pinnacle of our program is the black DFMEA Lite Expert belt. This level is reserved for those who have proven their proficiency at the practitioner level and are now ready to take on the mantle of responsibility for executing DFMEA Lite. This tiered approach ensures a structured and comprehensive mastery over DFMEA Lite, enabling our teams to effectively identify, analyze, and mitigate risks in our design processes. Let's get started on this journey of knowledge and empowerment. During this training, you will gain knowledge about what DFMEA is, its purpose, the different levels we have in mobile networks, the concept of robustness, and the DFMEA Lite life cycle. Now, let's shift our focus and talk a bit about what DFMEA is. DFMEA, or Design Failure Mode and Effects Analysis, is a structured tool used during product design to help identify and address potential problems. In simple terms, think of it as a meticulous planning process where engineers and designers examine every part of a product and ask, what could go wrong here? For each potential issue, they assess the likelihood of occurrence, the severity of the impact if it does occur, and strategize on prevention or mitigation. This proactive approach is essential in making the final product safer and more reliable by addressing issues before they manifest in real-world use. Now, let's introduce the P diagram, which stands for Parameter Diagram, another invaluable tool in our design process. The P diagram helps us visualize and analyze the various factors that could influence our product's performance. Starting with the noise factor, what external conditions or variables could negatively impact our product? Then, we consider the unintended result, how might these negative influences affect the customer's experience? Finally, we determine the control factor, what measures can we implement to prevent or reduce these negative effects? Together, DFMEA and the P diagram empower us to anticipate and counter potential design challenges, ensuring quality and customer satisfaction. Before we dive deeper, it's important that we're all aligned on the terminology we'll be using. Let's start with signal trigger. Think of it as the starting gun in a race. It's the catalyst that initiates a functionality. Moving on to signal parameters, these are akin to the runners on the track, the essential elements that our functionality needs to operate effectively. The ideal output. That's our finish line, it's the goal we're aiming to achieve with our functionality. Noise factors represent the hurdles along the way. These are the unexpected challenges that can disrupt our feature's performance. And if we encounter an obstacle that leads to an unintended result, an outcome we didn't anticipate. Lastly, we have control factors. These are our training regimes, the strategies and safeguards we put in place to navigate around those hurdles and prevent missteps. Together, understanding these terms will help us create a robust design that can withstand real-world challenges and meet our quality standards. Now, let's apply our understanding to a practical example. Picture yourself as a designer working on a toy car. The P diagram serves as our blueprint, mapping out the inputs or signals. These could be the buttons that make the car move or the remote control used by the child. Our outputs are what we expect the toy car to do, like speeding forward, lighting up, or making engine sounds. But what about the noise factors? These are the unpredictable elements, like rough surfaces, or even a pet that might bump into the car while it's moving. Unintended results are the possible outcomes we don't want, such as the car tipping over when hitting an obstacle. And to manage these, we have control factors, design choices like low center of gravity or durable bumpers to prevent tipping and withstand impacts. This systematic approach of the P diagram guides us in foreseeing and preemptively solving design challenges, making the toy car not only fun but also durable and safe for children. Through this lens, we can see how each component of the P diagram interconnects to form a cohesive and comprehensive design strategy. In mobile networks currently we have two levels of DFMEA. We encounter two pivotal levels of DFMEA, the system level and DFMEA Lite. The system level DFMEA takes a broader view, focusing on the interplay between different units within our network. It's about mapping out scenarios that span multiple components and ensuring that they work harmoniously. We look at the overarching interactions, the large-scale integration of systems, and how they coalesce to form a resilient network. This level is crucial for understanding and mitigating risks that arise from the complex interdependencies of our systems. On the other hand, DFMEA Lite hones in on the specifics. It zeroes in on the designs that are closer to the code, concentrating on the functional and technical aspects of the components we develop. This is where we dissect the minute details of our design, inspect the granular interactions at the code level, and fortify the technical robustness of each element. By distinguishing these two levels, we ensure a comprehensive approach, from the wide-angle lens of system scenarios to the close-up scrutiny of code-based designs. It's a dual-layered strategy that builds robustness into every facet of our mobile network infrastructure. Next, we're going to talk about why DFMEA Lite really matters. We'll see what can go wrong when we skip doing DFMEA. By looking at some examples where things didn't go as planned, we'll learn how valuable DFMEA Lite is for making sure our products work right. Imagine going to an ATM placed too high, or stairs that lead to a wall. Sounds absurd, right? But that's what happens when we don't think through our designs completely. It's funny until it's not, especially in our software. Let's pause for a moment and think about what robustness really means in the world we operate in. It's more than just a buzzword, it's what keeps our operations running smoothly. Imagine this: A software hiccup occurs, and it's not just a little blip on the screen, it's a full-on system meltdown. This isn't a drill, it's the real deal, and there's no simple reset button. Enter the truck roll scenario. No, it's not about getting your lunch on wheels, though that sounds great. It's that critical moment when a system is down for the count, and remote fixes are off the table. We're talking about deploying a team into the field, possibly to far off, hard to reach places, to get hands-on and fix the problem. And here's a number for you: the average cost of one truck roll. A staggering €40,000. That's right, it's not just the financial hit, it's the hours, the manpower, and above all, the trust of our customers that's on the line. When we suffer a truck roll, it's not just about the immediate costs, it's a dent in our image, a question mark against our name. Robustness, therefore, is not an optional extra, it's at the core of our business strategy. It's about crafting systems tough enough to handle whatever gets thrown at them, be it a surge, a glitch, or a random error. We need to be ready because in our business, robustness is not just technical, it's fundamental to our success and our legacy. Let's look at a real example that happened with our AEHC radio units. It's a story about a small mistake in our code that caused a big problem. So, in the software for our Mother 1 radio units, we used a piece of code that worked with timestamps, but there was a catch: this code could get overloaded if we weren't careful. For Mother 1 units, this wasn't a problem because they used low frequencies, but then, we used the same code for AEHC units without checking if it could handle higher frequencies. It was like setting a time bomb, and it went off on November 8, 2023, at 19:09 and 47 seconds. All AEHC radios had issues at the same time because of this. If we had done a DFMEA Lite on the original code for Mother 1, we would have thought about this problem. We could have added a safety check to stop the code from using frequencies that were too high for it, which would have saved AEHC units from this issue. This example shows us why doing DFMEA Lite is so important. It helps us think ahead and avoid problems that could happen later, saving us time, money, and keeping our customers happy. We keep mentioning robustness in our discussion, but let's pause for a moment and really think about what robustness actually means in our work. When we talk about software robustness, we're referring to a software system's ability to handle mistakes and keep running right, even when things get tough. Think of it like this: our job is to find and fix any issues that could make our product unstable, and if something out of the blue happens, we should be able to spot and solve the problem quickly. Let's look at a more formal way of putting it. Software robustness is how well a system or part of it can work correctly, even when faced with unexpected inputs or situations, or when something in the system goes wrong. Robust software keeps on performing well and keeps the system stable, even in surprising conditions. Let's dive into what makes software robust. Think of these as the strong pillars that support our top quality software. First, we have exception handling. Imagine if you gave up every time something unexpected happened. That's not ideal, right? Well, robust software doesn't give up. It handles surprises, logs them, and keeps going. Next is fault tolerance. Think of it like your car's suspension. You hit a bump, but you keep moving. Our software needs that kind of resilience to keep running smoothly, even with some faults. Then, resilience to input. Our software will meet all kinds of data, some normal, some not. Robust software can handle this without crashing. Recovery is about bouncing back. If our software or hardware has a problem, it quickly gets back to normal, without losing progress. Resource usage is about efficiency. Our software uses things like memory and CPU wisely, not wastefully. Security is crucial. It's like locking your doors. We keep our software safe from attacks and misuse. These pillars are linked with other important qualities like reliability, availability, recoverability, and maintainability. Together, they create a strong, reliable software that can handle real-world challenges. Reliability means our software works well all the time. Availability means it's always ready to go. Recoverability is our backup plan to keep our work safe. And maintainability means we can update and improve our software over time. Remember these pillars during our DFMEA Lite process. They guide us in making software that's not just good, but great. This slide paints a clear picture of what robustness means for our software in the real world. Imagine our software as a network of processes. Like the flowchart you see here, it's designed to handle transactions between objects. But what happens when things don't go as planned? Invalid inputs from users, miscommunications between components, surprises from third-party libraries, or even a new release that changes the game. Look at the cloud with questions. These are the unexpected challenges we need to be ready for. And that thought bubble on the right, it's about being prepared when something in our system fails. We need the right logs to tell us what happened, like a detective looking for clues. It's all about designing with foresight. It's not just about making things work, it's about making them work when the world around them doesn't. That's what robustness in practice looks like. Now, we're entering a vital section titled DFMEA Lite Life Cycle. In this part, we'll explore the journey of DFMEA Lite. We'll discuss when to start thinking about it, the steps involved, and where the process concludes. It's like mapping the life of a product from the drawing board to the real world. Understanding this life cycle is key to integrating DFMEA Lite into our work, so let's get ready to dive in. Okay, let's break down the DFMEA Lite life cycle. It's our roadmap to building software that's not just good, but great and reliable. First up, planning. Imagine we're prepping for a big adventure at the FS2 milestone. We map out all the tasks, including DFMEA Lite, to ensure we've allocated enough time for quality checks by the P2 milestone. We need to have our full plan detailed in Jira, ready for the team to get going. Now, onto high-level design. This is where we draw up the master plan. We create diagrams that lay out our features structure, like a blueprint, and write up everything about it, what it's going to do, what parts of our system it'll touch, what we need to start, what we expect to get out, and what conditions need to be met. It's our features detailed story that we'll discuss and refine until it's crystal clear. Next is the discussion stage. Our DFMEA Lite facilitator leads the charge, bringing everyone together for a thorough walkthrough. We dissect our P diagrams, pinpointing any technical risks for simpler tasks. A quick chat during a regular meeting will do for more complex ones. We set up a dedicated session to dive deep and ensure all potential issues are caught and dealt with. Then, we hit the implementation phase. Here, our well-crafted plans and all the control measures we've identified are put into action. We're in the trenches now, building our feature to be robust and to perform flawlessly. Finally, we have improved during the maintenance phase. We revisit any bugs or overlooked scenarios that slipped through. We take these learnings and compile a checklist of guiding questions for the DFMEA Lite of future features. This isn't just about fixes, it's about enhancing our processes to be more bulletproof with each release. And that's the DFMEA Lite life cycle for you. By sticking to these steps, we ensure that what we create isn't just functional, it's built to withstand the test of time. Let's talk about how we plan DFMEA Lite, focusing on how we estimate effort and organize our work. Before the FS2 milestone, our team leaders have a significant task. They need to determine how much work is involved in three key areas of DFMEA Lite: preparing the designs, discussing them in meetings, and implementing the control factors. It's crucial for our DFMEA Lite facilitator to work with the FS2EE owner to ensure we allocate enough time for these tasks. As we approach the I1, P2, or I3 milestones, it's time to outline our tasks in Jira. Properly setting up our backlog is essential. The local product owner is responsible for preparing the backlog structure, but the DFMEA Lite facilitator should also collaborate to ensure all DFMEA Lite related efforts are included. Take a look at the template of the structure that incorporates DFMEA Lite activities. We employ what's known as a block relation between our preparation epic and our implementation epic, which is akin to saying, we can't start building until we've got the necessary materials. Also, pay attention to the labels. We need all of them for the ability to trace all effort related to DFMEA Lite. This will be our foundation for considering how we can improve the efficiency of the process. This slide shows that we're not just creating to-do lists, we're establishing a clear path from beginning to end. By doing so, we ensure that nothing is overlooked and everything we build is robust. Now, we'll explore the P diagram and its role in ensuring our product's robustness, navigating from conception to reality. We begin with signals, which are the triggers and parameters that start and manage the functionality of our system. Think of these as the initial inputs and settings required to get the process going. Moving on to the ideal output, this is our sunny day scenario, the perfect outcome we aim for where everything goes as planned. Next, we articulate the function. This is the narrative of our tale, the process that transforms our inputs into the desired outputs, crafting the journey from start to finish. We then address noise factors, which are the unpredictable elements that could disrupt our story. During our discussion, we'll use a checklist to ensure we cover all lessons learned from earlier issues and invite contributions from the audience to gather as many perspectives as possible on what can go wrong. As a result of these noise factors, we may encounter unintended results, the negative experiences of our customers, unexpected consequences of noise factors that we need to foresee and mitigate. To navigate through these unexpected consequences, we identify control factors, our strategies and safeguards designed to address and rectify the unintended results caused by detected noise F0 actors. At the conclusion of our discussion, we aim to compile a list of tasks, Jira tasks for implementing these control factors, as well as tasks for system component tests that simulate the noise factors. This ensures that our product is not only conceived with an ideal scenario in mind but is also tested and fortified against potential adversities. After we've launched our feature, we might find that it's not perfect, bugs happen, and we call these prontos. But here's the thing, mistakes are only truly errors if we don't learn from them. So, after we fix these prontos, we need to dig deep. We ask ourselves, why did this happen? Improving our DFMEA Lite process starts with this kind of analysis. It's especially important for prontos that happen just once or only sometimes, those that are traced back to a design error or something we should have caught during the design review. If a problem is rare, it usually means we didn't have the right tests in place to catch it earlier. Sure, we fixed it now, maybe even came up with a test for it, or put a workaround in action. But we need to ask ourselves, why didn't we think of this during our initial DFMEA Lite? We take this back to the team for a thorough discussion. We brainstorm to identify the questions we should have asked that would have led us to predict this issue. These questions then become part of our DFMEA Lite discussion checklist in our dedicated tool. It's how we turn our mistakes into learning opportunities, ensuring that with every feature we develop, we're not just solving problems, we're preventing them. Now, let's take a look at a good example. In this section, we will examine a case study that illustrates what it means for DFMEA Lite to be well planned and executed. It's a showcase of best practices and successful outcomes when everything aligns perfectly from the planning stages through to implementation. In this segment, we're showcasing a solid example of the planning phase for DFMEA Lite. Here's how a well-prepared epic should look. First, each epic is tagged in a meaningful way, which makes it clear and identifiable. This helps in tracking progress and understanding the scope at a glance. Second, the epic contains only tasks that are relevant for preparation and the meeting, ensuring a focused and uncluttered workspace. Next, notice how each task within the epic is properly labeled. These labels serve as signposts, guiding us toward the right actions and helping maintain organization throughout the process. Furthermore, this epic correctly blocks epics for development and integrations, illustrating a structured approach to project management. It acts as a gatekeeper, ensuring that no development starts without the necessary groundwork laid out in the DFMEA Lite. With this approach, we lay a strong foundation, ensuring that our DFMEA Lite is not just planned but planned effectively. In this good example, we're delving into the high-level design, which is a blueprint for our development process. The design begins by targeting a specific repository or service, ensuring that our focus is precise from the outset. We then provide a short description of the feature and its purpose, giving everyone a clear understanding of what we aim to achieve. We meticulously define the preconditions and triggers. Preconditions set the stage, detailing what must already be in place for the feature to work. Triggers are the events that initiate the function, like starting engines. The flow of the initialization phase is laid out step by step. This methodical breakdown guides the development team through each stage, ensuring that each part of the system activates correctly and interacts as expected. By structuring our high-level design in this way, we ensure clarity and direction for the team, paving the way for a smooth and predictable development cycle. Continuing with our high-level design, we now focus on the runtime phase, meticulously described step by step to illustrate the dynamic flow of operations. The process begins with a request to take a snapshot, initiating a sequence of interactions between components, each step carefully choreographed to ensure precise execution. From preparation to execution, and eventually to the cleanup, each action is tracked to maintain the integrity of the process. Moreover, we delve into additional technical details, providing extensions and error handling strategies. This includes specific responses to various scenarios, ensuring that our system is not only responsive but also resilient in the face of unforeseen circumstances. By detailing these sequences and contingencies, we create a robust framework that not only directs the flow of runtime operations but also anticipates and manages potential exceptions. For the final part of our high-level design example, we focus on the outcomes and supportive information. Post-conditions are defined as the ideal output of the process, detailing the state of the system once the operation is complete. For instance, ensuring that automatic register trace is enabled successfully and that register trace dump files are included in snapshots. Accompanying these details, notes provide additional context and clarification. These notes might include technical specifics, such as the designation of RAD flags or the support structure of SOC subsystems. References to related documents and resources are included, offering avenues for deeper understanding and further exploration. And crucially, an attached UML flow diagram visually represents the process and dependencies, giving us a bird's-eye view of the system's interactions during runtime. This diagram acts as a roadmap, guiding stakeholders through the complexities of the system's behavior. Together, these elements illustrate a comprehensive and well-thought-out high-level design, setting the stage for successful implementation and maintenance. This P-diagram is a prime example of structured product design and functionality mapping. It begins with signals, the starting points for our system's processes. These are the vital inputs and triggers necessary to initiate the system's operations. Following this, the ideal output section outlines the sunny day scenario, our goal for what happens when everything runs perfectly. Next, we provide a feature short description. This gives a concise yet thorough overview of what the feature is and what it's meant to achieve. The noise factors come into play next, identifying potential disruptions that could affect the system's performance and stability. We then examine the unintended results, the outcomes we want to avoid but need to plan for if noise factors aren't adequately controlled. Finally, we define control factors, our planned responses to these unintended results, ensuring we have measures in place to handle any issues that arise. Each part of this diagram works together to give us a comprehensive view, helping us anticipate challenges and prepare robust solutions for a reliable product design. We now look at the discussion closure phase, where tasks for control factors preparation are presented. Notice how each task is clearly labeled with the D.F.M.E.A.control factor label. This labeling is not just for organization, it ensures that each control factor is traceable and receives the attention it deserves in our DFMEA Lite process. From handling exceptions in our API methods to changing default file names and checking file sizes, each task represents a commitment to addressing and mitigating potential issues. These tasks form the bedrock of our approach to risk management, turning plans and discussions into actionable and measurable work items. It's this level of detail and attention to the labeling and execution of tasks that exemplifies a good example of DFMEA Lite in action. Here we have a sterling example of how to store knowledge from our past experiences, essentially the lessons we've learned from bugs we didn't consider previously. This slide displays a checklist that catalogs questions and descriptions of issues encountered. It's a strategic repository that aids us in refining our process. Each entry on this list represents a scenario we've faced, prompting us to check and balance configurations, adapt system parameters, ensure log integrity, and consider operational modes. By incorporating this checklist into our DFMEA Lite process, we actively remind ourselves of the noise factors that slipped by us before. This vigilance ensures that in our future endeavors, we remain one step ahead, mitigating risks before they manifest into issues again. Such a methodical approach to knowledge retention is invaluable. It does more than just solve problems, it prevents their recurrence, making our processes more robust and our products more reliable. Let's take a moment to recap what this course has covered before we dive into the exercises. You should now have a clear understanding of what DFMEA is and the purpose it serves. You've learned about the different DFMEA levels we have in mobile networks. The concept of robustness should now be clear to you, what it means and why it's important. And finally, you've been introduced to the DFMEA Lite life cycle, and the steps it encompasses. With this knowledge, you're well prepared to apply these principles in practice and contribute to the robustness of our products. Now, equipped with the insights from our session, I encourage you to put theory into practice with the upcoming exercise. It's a valuable opportunity to see in action what you've learned and solidify your understanding of DFMEA in a hands-on environment. Now let's shift gears from learning to doing. It's time to apply your new skills in a practical exercise. Start by identifying a certified DFMEA Lite facilitator within your unit. This person will guide the initiation of the DFMEA Lite process. Examine the tasks in the backlog, pay attention to their descriptions, labels, and how they link together. Understand how each task is estimated. Check also FS2 effort estimations for selected features. Engage in a high-level design review. Collaborate with the design owner to gain deeper insights into the design process. Observe a DFMEA Lite discussion meeting. Watching the process unfold is a great way to see DFMEA Lite in action. Finally, participate in a retrospective for a pronto related to a design error. Here, you'll witness the creation of new discussion triggers, a critical step in continuous improvement. Through these steps, you'll gain hands-on experience and contribute to enhancing the robustness of our projects. Thank you for participating in this training. Your engagement and effort are what make our sessions both valuable and successful. We would greatly appreciate your feedback on this training experience. It is crucial for us to understand your perspective. In particular, we encourage you to share any constructive criticism. Negative feedback is not just heard, but it is also a significant trigger for us to improve our materials. Your honest insights ensure that we can refine and enhance the training for everyone. Remember, every piece of feedback is a step towards making our training more effective and beneficial. Thank you once again, and we look forward to hearing from you.